Given the series 16, 12, 9, 27 over 4, calculate the sum of the first 10 terms. Question number 1. How do you calculate that? So let us first write what we're given. From the question, you know that A is given by 16, right? And then the common ratio R, we have to calculate it, is given by T2 over T1. And then our term number 2 in this case, that is 12 over 16. And then this is 12 over, that is 3 over 4, which is that quarter. You can confirm it by also checking if T3 over T2 will be the same, 9 over 2. But there's no need. You just trust in just to see. 9 over 12, that is 3 over 4. Yes, that is our common ratio. And then they said the sum to the S10. That's what we are calculating. The formula for Sn is given by Sn is equals to A into R to the n minus 1 over R minus 1. And then S10. That's what you are calculating. The sum of the first 10 terms is. And then A, that is 16. R, that is 3 over 4. And then the number, that is 10 minus 1, everything over 3 over 4 minus 1. Then let us press down calculators. So on your calculator, okay, from a calculator, the answer is 60.395. Okay, 60.4. 60,4. Next page is then number 2. What's the question? Determine the sum to infinity. The sum to infinity is given by A over R minus 1. That is actually 1 minus R. Sorry, my mistake here. 1 minus R. Yes. And then we already have A, that is 16 from the question. 16, 1 minus, and then our common ratio, we calculated it was 3 over 4. Then just have to press down our calculators. Okay, that is 64. Okay, one more. Write the series in sigma notation. Number 3. Sigma notation. Okay, obviously we need to find Tn first, so we'll never calculate Tn. Let's get Tn. Then Tn, this is an geometric series and is given by A to the Rn minus 1. And then A, 16, I think. Yeah, that is 16. Then times our R is 3 over 4. We calculated it here. This is R. Then to the n minus 1. There is no need to simplify, so we just plug it here. 16 into 3 over 4 to the n minus 1. And then we need to find the term here. Where does it start? So what do we need to do here? The first term was 16, right? So we'll have 16. Okay, to get the n from the bottom part, we just have to find Tn, the nth term for the first term, and then that first term was 16. So substitute 16 here, 16. Then let's simplify to solve for n. Divide both sides by 16, 16 over 16 equals to 16 into 3 over 4 n minus 1. Everything over 16, cancel out, cancel out. This one, 16 over that is 1 obvious, and 3 over 4 to the n minus 1. Then to solve for n here, let's change n to 3 over 4 to the exponent of 0. Because we know any number raised to the exponent of 0 comes back to 1. If it's x to the exponent of 0, this is 1. If it's 2 to the exponent of 0, this is 1. Any number raised to the exponent of 0 equals to 1. This is why we just change this to the exponent of 0, so that this solution can be solvable. 3 over 4 to the n minus 1 on the right hand side. Then laws of exponents. Equating powers of the same base. We also equate the exponent, and the base is the 3 over 4. So therefore 0 equals to n minus 1. Add 1 both sides, you're left with n equals to 1. Then this is n equals to 1. And then the question said that write the series in sigma notation. If it's for the first 10 terms, then we're going to write 10 here. Then, then that will be it. 10 on top, 16. Yes.